Hi and Assalamualaikum everyone. Welcome to our video. Before we start our video, let me introduce our group members.
In this video, we will be talking about the analysis of function. Firstly, we will go through the introduction, problem statement and solution, and lastly, the conclusion. The analysis of functions involves investigating and understanding the properties, behavior, and relationship within mathematical functions. These include examining features like domain, range, critical points, asymptotes, and symmetry. The first problem statement is, given the function f(x) equal to negative x over 1 minus x plus 4. A. Find the x-intercept and y-intercept if any. B. Find the vertical and horizontal asymptotes. C. Determine the intervals whether it's increasing or decreasing. D. Determine the intervals whether it's concave up or concave down. E. Find the inflection points if any. And lastly, by using all the information, sketch the graph of f(x) using decimals. You are required to setting the x-axis from negative 9 to 10 and y-axis from negative 2 to 10. The second problem statement is, given the function f(x) equal to negative x cubed plus 9x squared minus 24x plus 2. A. Find the x and y intercepts if any. B. Find the first derivative of f(x). C. Find the critical values and critical points. D. Construct the interval table. Find the interval where the graph of f(x) is increasing and decreasing. E. State the maximum point and minimum point. F. Find the second derivative of f(x). G. Find the inflection value and state the inflection point, if any. H. Find the interval where the graph of f(x) is concave up and concave down. I. Using all the information, sketch the graph of f(x) using decimals. You are required to setting the x-axis from negative 6 to 10 and y-axis from negative 30 to 10.
So, let's move to the first question. Given the function f(x) equals to negative x over 1 minus x plus, find the x-intercept and y-intercept. To find the x-intercept, f(x) equal to 0. So, negative x over 1 minus x equal to 4, and we calculate until we get 4 over 5 for x-intercept. For y-intercept, substitute 0 into the x, so y is equal to 4. Next question, find the vertical and horizontal asymptote. First of all, we need to simplify the equation, and we get 4 minus 5 over 1 minus x. After that, find the vertical asymptote. So, let 1 minus x equal to 0, and we get the answer x equals to 1. And then, we apply x equals to 1 to the analysis of vertical asymptote. So, lim x approaching to 1 negative, 4 minus 5x over 1 minus x equal to negative infinity. And the other one is lim x approaching to 1 positive, 4 minus 5x over 1 minus x equals to positive infinity. Last but not least, horizontal asymptote, which lim x approaching to the plus minus infinity, 4 minus 5x over 1 minus x. And then we use high power method to solve this question, and the answer is y equal to 5. Determine the interval where is increasing or decreasing. First of all, we use formula f prime x equals to vu prime minus uv prime over v square, and the answer is negative 1 over 1 minus x times 2. Then, let f prime x equals to 0. Fx is undefined when 1 minus x squared equals to 0, so x equals to 1. After that, we use test table to identify the increasing and decreasing interval. For the first interval, we use 0 as test value and we found it negative. While the second interval, we use 2 as test value and we also found it negative. So this interval is increasing, which is negative infinity 1, union 1 infinity. Next question, determine the interval where is concave up or concave down. First of all, we simplify the equation and do the same calculation as question 3. We also use test table for this question, and we got the first interval is negative and the second interval is positive. So the answer is concave up is 1 positive infinity and concave down is negative infinity 1. Next, find the inflection point. So when x equal to 1, substitute 1 into x and the answer is undefined, so the inflection point does not exist. Last but not least, we use decimals for this question, and this is the graph that we found.
The first question is find the x and y intercepts, if any. For x-intercept, when y equal to 0, 0 equal to negative x cubed plus 9x squared minus 24x plus 2. So we're going to get the value of x is 0.09 4.46 and 4.46. While for the y-intercept, when x equal to 0, f0 equal to minus 0 cubed plus 9, 0 squared, minus 24 plus 2. And we're going to get the value of y is 2. B. Find the first derivative of fx. Fx equal to negative x cubed plus 9 x squared minus 24x plus 2. While f prime x equal to negative 3x squared plus 18x minus 24. C. Find the critical values and critical points. F prime x equal to 0, f prime x equal to negative 3x squared plus 18x minus 24. And the critical value is 2 and 4. So the first step, we're going to do the first critical value, which is f2 equal to negative 2 cubed plus 9 times 2 squared minus 24 times 2 plus 2. And the answer is negative 18. While for the f4, it is equal to negative 4 cubed plus 9 times 4 squared minus 24 times 4 plus 2. And the answer is negative 14. So the critical point is 2, negative 18, and 4, negative 14. D. Construct the interval table. Find the interval where the graph of fx is increasing or decreasing. The first interval is negative infinity and 2. The test value for it is 1. The sign is negative, and the conclusion is it is decreasing. The second interval, 2 and 4. The test value is 3. Sign positive, it is increasing. And the last one, 4 and infinity. The test value is 5. Sign is negative, and it is decreasing. So the increasing interval is 2 and 4, while for the decreasing interval, negative infinity 2 and 4 infinity.
Next, we have minimum and maximum point. Minimum point we got 4 and negative 14. Maximum point we got 2 and negative 18. After that, we need to find the second derivative of fx, which is negative x cubed plus 9x squared minus 24x plus 2. We differentiate and we got f prime x equal to negative 3x squared plus 18x minus 24. And we differentiate again, so we got negative 6x plus 18. Then we need to find the inflection value by using our latest equation that we have differentiated just now, which is negative 6x plus 18 equals to 0. And we simplify until we got x equal to 3. Second, we use substitution method. We substitute 3 into equation of fx, and the answer is equal to negative 16. So our inflection point is 3 and negative 16. Last but not least, we can determine which one is concave up and concave down by using this table method. Interval f prime s equal to concave up, which is negative infinity and 3. Interval f prime s equal to concave down 3 and positive infinity. Last one, I include the picture of our graph. By using all the points, we got this kind of graph that we chose the range of the graph for x-axis minus 6 less than or equal to 10, and the y-axis minus 30 less than or equal to 10.
In conclusion, graphs have diverse real-life applications. For instance, social networks can be represented as graphs to analyze relationship, transportation system as graphs to optimize routes, and supply chains as graphs for efficient logistic planning. Graphs provide a versatile framework for modeling and solving various problems in fields such as computer science, logistics, biology, and sociology.